right, well, we are here yet again, 3 p.m. It's an afternoon, and we're going to be doing factoring. So today's topic is all about factoring polynomials. So, just as I promised, today and tomorrow we're going to be talking about factoring polynomials. Today we're going to look at some of the more fundamental aspects of factoring. We're going to be looking at the greatest common factor, going to be looking at factoring by grouping, and then we're going to be looking at factoring trinomials where the lead coefficient is 1. And depending on how far we get, we might even look at some of those examples where the lead coefficient is not 1 when it comes to factoring trinomials. So let's go ahead and get started. One of the things we need to understand about factoring is what it means to factor. So whenever you are instructed to factor, understand that to factor means to rewrite as a product. Factoring means to rewrite as a product. That means we're going to rewrite some expression using multiplication. Okay? So recall the distributive property from a long time ago. See, the distributive property would have looked like this. It would have said if you have a factor times a group like this, b plus c, then we would take this value right here, and it distributes and it hits both of these guys, like that. And when we do that, so it looks like a times b plus a times c. That is the distributive property, but we've spent so much time thinking about how it goes in this direction, right? That's how we tend to think of it. But there's the other side of this. Since this is an equation that allows us to go backwards. And so what that looks like is that if you have a times b plus a times c, if we can identify that there's this common factor, this common piece in terms of multiplication between the two terms, we can write that out in front, and we can put the remaining factors inside a set of parentheses like that. So these two guys, I don't want to say two, this is the same factor, so that common factor is written out here in front, and this is what we call our GCF, our greatest common factor. Okay? Now, let's take a look at this example, just so we understand what we're saying here with the distributive property going backwards. If I say 7x plus 14, we want to make sure we understand that we can rewrite this to say 7 times x plus 7 times 2. What we're identifying here is that 7 is the common factor between these two terms, and so this common factor right here of 7 can now be written in front of everything. So we'd say 7 times these guys that are here in black, the x plus 2. And this is factoring. This is rewriting a polynomial, rewriting something that's made up of multiple terms, and we're writing it in terms of multiplication now. So we can say 7 times x plus 2. And this concept of rewriting through multiplication allows us to do a lot of big, crazy things later on. So if we don't have factoring, we can't do the fun simplify. We can't solve some of these equations that we're going to see coming up later. All right, so let's try this. 25x minus 35y. we want to find the greatest common factor here. And the greatest common factor between these two guys, we're looking at the coefficients. The greatest common factor between 25 and 35 is 5. That's the largest number that goes into those guys. And so that's what we're going to factor out of each of these. If we look at the variable factors, x and y, these guys don't have anything in common. One's x and one is y, so we're just going to leave them as they are. So with the 5 out here, when we talk about factoring, you can almost think about, when I say that we're factoring out 5, think about dividing 5 out of each of these guys. So if I take 25x and I divide it by 5, I'm left with 5x. If I take negative 35y and I divide by 5, I have negative 7y. That's factoring. You're just dividing out that common factor from each of those terms. Make sure that you look inside here, the 5x minus 7y, and see, is there anything else that these guys have in common? Oftentimes, we take out something that's a common factor thinking, okay, good, we're done, but then we forget that there's something else that they have in common. But there's nothing that 5 and 7 have in common, nor is there anything common between x and y. So that's all that we have. If I take 8x to the 5th plus 2x to the 3rd, and I want to identify the common factor here. If I look at the coefficients, 8 and 2, we see that there is something that these guys have in common. They both contain a factor of 2. So I can factor out a 2. But if that's all I factor out, I'm missing something, because they both contain x. They both contain factors of x. So the trick here, the thought process, is to figure out how many factors of x can I take out of both of these guys without taking out too much or taking out too little. So we know that I can factor out x, but the amount of factors of x that you factor out is going to be limited by the smallest power that you see. So the most amount of x that you can take out is going to be 3 factors of x. This guy has 5 to give, this one only has 3, so he is the limiting factor. So now let's divide out that common factor, and let's see if it really is the greatest common factor. Maybe I missed something, so let's just check that out. If I do 8 divided by 2, I get 4. I had 5 factors of x. I took out 3 factors of x. So if I had 5 and I factored out 3, I'm left with 2 factors of x. And then here, this is where things get a little tricky. It's very easy to make a common mistake and get flubbed up. I had 2, I factored out 2. Now remember, we're not subtracting out that 2, we are dividing it out. So whenever I take 2 divided by 2, I get 1. And I need to write that 1. I had x to the 3rd, I took out all factors of x so that no x's remain. So it's just 1. A really easy way to check your factorization is to multiply. If I were to take 2x to the 3rd times 4x squared, that gives me 8. And if I look at the x's, x to the 3rd, and x squared gives me x to the 5th. We had this video last week about properties of exponents, and we said that when you multiply, you add the powers. If I continue distributing, 2x to the 3rd times 1 is just 2x to the 3rd. So that's all that we can do here. Now, it is possible that sometimes we take out what we think is the greatest common factor, but then we miss something. So let's look at this again. Suppose that you are so focused on the coefficients that you just take out 2. You divide this by 2 and you get 4x to the 5th. You divide this by 2 as you factor it out, so you get a 1, which leaves us with x to the 3rd. Now that looks okay, except for the fact that these guys both contain factors of x. So that means we missed the common factor here of x to the 3rd. So it's not that our answer is wrong necessarily, it's just that we didn't factor enough. So we need to take out the x to the 3rd as well. So the 2 is still out there because you need to remember this. This is 2 times that. So anything else that we factor out is going to be connected through multiplication. So that's going to be 2 times x to the third times, and what's left over here? We still have the 4 because we didn't do anything with the coefficients. This was just working on the variables now. 3 factors of x, take away 3. So 5 minus 3 gives us 2. Plus, you had 3 factors of x, you took them all away, so no x's remain. But remember, if I don't have anything here, and I just end up having this as an answer, this is not going to multiply to give you the original problem. So we need to have a 1 right there, so that when I distribute, I get back to the original. Always make sure that you multiply to see that your final answer is the same as the original. Now, just because that works out doesn't mean that you are 100% correct, because it could be that you're missing a common factor that you just didn't see at the beginning. We're going to talk about an easy way of finding the common factor, especially when we start having a bunch of numbers and maybe it gets hard to kind of track all that stuff. Okay. Let's try taking 10 x to the 7th minus 40x to the 6th plus 25x to the 4th. So now we're trying to find a common factor for all 3 of these terms. Is there something that they all have in common? Now, to avoid being overwhelmed with everything that you see here, just do it piece by piece. And what I mean by that is, first, focus on the coefficients. If I look at 10, 40, and 25, is there something that they all have in common? Right, that will be the greatest common factor, Kevin. The common factor for just the coefficients is 5, and then when we turn our eyes to the variable components, these guys all have x, so there is something they have in common, and the most amount of factors that you can pull out is going to be limited by the smallest number that you see here, which is x to the 4th. So I can take out 5x to the 4th, and that's going to be it. So I had 3 terms here. When I take out a common factor, I should still have 3 terms left inside here. So 10 divided by 5 gives us 2. We had x to the 7th. We take out 4 factors of x, and we're left with 3. To the next term, this is a minus 40. You're not taking away 5, remember. You are factoring out the 5. You're dividing it out because it's all about multiplication here. So 40 divided by 5 is 8. Then x to the 6th, you took out 4 of those factors, leaving us with x squared. And then here, 25 divided by 5. So we get 5, and well, we took out all factors of x. We had x to the 4th, we took that out, and there we go. Okay, so is there anything else that these guys all have in common? No. Between 2, 8, and 5, there's nothing they have in common. These 2 terms have x in common, but the 5 doesn't. So you have to stop right here. All right, let's squeeze one more here onto this page. So x to the 23rd, y to the 50th, minus x to the 41st, y to the 19th. So if you look at this, what do you think the GCF is going to be for these 2 guys? Or is there one? Maybe there's nothing they have in common. But wait a minute. I see that they both have x, and they both have factors of y. So surely there's something that we can do with that. So, if I look at these x's, this one has 23 factors of x, this one has 41 factors of x. So, the most amount of x that I can take out of both of these guys will be limited by the smaller number right here. So it is going to be x to the 23rd And as Kevin is pointing out in the chat, we can also take out 19 factors of y. You've got 50 here, but only 19 here, so this guy's going to limit you. So this is our GCF. But then what's left over? And this is where we go term by term. Don't look at everything up here at the same time, except when you're trying to identify the GCF. Look at just this guy right here. I had 23 factors of x, and I factored out 23 factors, so no factors of x remain. For the y's, I had 50, I took out 19, so I do have some y's left over. And I have 31 factors of y remaining. Then I move on to the next term. So you've got two terms here, and we're supposed to have two terms inside here. For this next term, I had 41 factors of x, and I factored out, I divided out 23. So 41, take away 23, I'm left with 18 factors of x. I had 19 factors of y, and I took out 19 factors of y, so none of them remain. And so right here, we're going to be done. These guys don't have anything else in common. There's no other factoring technique that I can apply here, so that's it. What I wanted you to see is that sometimes you have to take out a lot of different pieces for the greatest common factor. And I also want to make sure you understand that these two guys don't go together. There is subtraction separating these terms at the beginning. There's subtraction separating these terms right here. These guys do not get to go together. They don't somehow squeeze together because it's subtraction, not multiplication. So you leave it as it is. All right. So that's the basics, getting the greatest common factor out of the way. Because all the other graphing stuff that we talk about tends to rely on identifying and finding the greatest common factor. All right. So the next part is about a technique called factoring by grouping. And through some posting on social media and some conversations I was having, I found out that not everybody learns factoring by grouping. It's kind of shocking because I just thought that was common to everybody, but depending on where you grew up, you might not see it this way. You might have seen it a completely different way. So for factoring by grouping, if we start off small like this, and I say xy plus 5y, I hope that you guys can tell that there is a common factor between these two terms. I'll try to make it pretty explicit for you. They both contain a common factor of y. This is x times y and 5 times y. So that y is going to be your common factor. And so I just factor it out in front. And then I'm left with the pieces that are left over. So I'm siphoning, I'm pulling the y away from both of those. And when I do, I'm left with x plus 5. And that's it. And this is really the very, very basics of the greatest common factor stuff that we were just doing on the other page. If I do x smiley face plus 5 times smiley face, that's just like the last problem that we did. I know it looks kind of weird, but there is a point to this. These guys both have in common, as part of their individual products, as part of their individual terms, they have smiley face in common. So smiley face is now a common factor, and that's also going to be multiplied times x plus 5, because that's what's left over, x and 5. And so if you guys are okay with what I'm doing here, identifying that this was my common factor and that gets factored out in front, smiley face was the common factor and he gets factored out in front. If we're all okay and on the same page with that, then I can make it a little bit more challenging. It makes it look more difficult, but it really isn't. It's still the same concept. So if I say x times x minus 9 plus 5 times x minus 9, sorry, we see here that we have a big factor that's common. So common factors don't have to be just individual pieces, small guys, single pieces. They can be groups like this. X plus 9 is common from both of these. And so it's that x plus 9 that gets factored out in front, and he is connected to both x and 5. So we go x plus 5 like that. That's all there is. I'm serious. That's all we have to do. I'm not asking you to multiply anything out. I'm not asking you to do anything different. I just want to factor. I want to be able to rewrite our polynomials using multiplication. All right, so now that we have that out of the way, let's see this in action. Let's take x to the third plus 4x squared plus 10x plus 40. Now, if we look at this entire polynomial, as a whole unit, we want to be looking for a common factor for everything. But there's not a common factor for everything. You might look at this and say, oh, 4, 10, and 40 all have a common factor of 2, but this lead term doesn't. Or you might say, these first 3 terms all have x. It's true, but the last term does not have x as a factor. And so because of that, there is no common factor for the whole thing. So here's what we're going to do. We're going to create groups. I'm not using parentheses for my groups. I'm just going to underline these guys to highlight them. This first group, x to the third plus 4x squared, there is a common factor for these two terms. And that common factor is x squared. I'm going to factor x squared out of each of these terms. I'm going to be left with x plus 4. Now, I like to use different colored pens here to highlight what's left over so you can see where things go from one part of the problem to the next. You can identify here that x and 4 have no other common factors, so we're good. Then we move on to the second group. Now, this is where we tend to have a lot of problems. This sign here that leads off that second term, or the second group, excuse me, you bring it down exactly as you see it. If that's a plus, you bring down a plus. If it had been a minus, you bring down the subtraction sign. Then you look at the common factor, or you try to find the common factor for 10x and 40. And the greatest common factor for these two terms is 10. So now that we divide, or now that we have the common factor, we divide it out of each of these. So we have x, 40 divided by 10 is plus 4. And so I feel like we're doing good here because you notice that x plus 4 is now a common factor, just like it was in the last example that we did. We had x minus 9 as a common factor, and what did we do with that? We brought that out front as a single unit, and it was going to be multiplied times the guys that were left over, the x plus 5. And that's what we're going to do right here. We're going to rewrite this by bringing that greatest common factor that we've identified here of x plus 4. We write that in front. And the x plus 4 is connected to two pieces. It was connected to x squared and plus 10. And so now we've taken this 4-term polynomial and we've been able to rewrite it as a product of two smaller polynomials. And this is going to be great for us because next week we're going to be using these same factoring techniques to help us solve equations that look just like this. Now, I know some of you out there are saying, well, I did mine a little bit differently. My answer doesn't look like yours. The thing to understand about factoring is that this is multiplication. And as I've said before, the great thing about multiplication is that the order doesn't matter. And since the order doesn't matter, you may have this written as x squared plus 10, and then maybe you have the x plus 4 as the second factor. It doesn't really matter because these guys are exactly the same. And that's just one of the fantastic things about multiplication and factoring in general. Factoring is totes the bomb or something like that. All right, let's try another one. So let's try 3x to the third minus 6x squared plus 8x minus 16. Again, the first thing we want to do is to see if there's a common factor for everything here. And no, there's not a common factor for everything. We kind of run into the same situation that we had in the problem above, where some of these guys have a common factor, but not everything. Not all 4 terms have a common factor. So let's factor by grouping. Let's take this first pairing right here, 3x to the third minus 6x squared, and let's take out the greatest common factor for those 2 guys. Again, we can do this piece by piece. Between 3 and 6, the common factor is 3, and they both contain x. The most amount of x that I can take out of these guys is going to be x squared, because that is the guy that kind of limits us right here. Greetings, Nightwolf. Yes, 3x squared is going to be the common factor for the first group, and we're left with, take out the 3, you just have a 1, x to the third, you take out 2 factors, and you've got 1 left. And then over here, 6 divided by 3 is going to give us minus 2. You had x squared, you took out x squared, and so we're done with that. And then, yes, in the second group, when we look at this, there's a plus. The common factor here is 8, and you're going to factor that out of each of these guys. Now, if this problem really can be factored by grouping, I had x minus 2 left over here, then I better have x minus 2 left over here. If I don't, then either the problem can't be factored by grouping or we did something wrong. Alright, so 8x, factor out the 8, we have x. Negative 16 divided by 8 gives us a negative 2. So, those guys are exactly the same, just like I planned it. So we factor that out in front. So x minus 2 times the stuff that's left over, 3x squared plus 8. Easy peasy, right? See, who knew math could be so much fun? Oh, wait a minute, I did! One of the things I do want to point out to you guys is the proper use of your equal signs. We were saying that this polynomial equals this, which then equals this final step. So proper use of equal signs is paramount. It makes your work look really nice and neat, and it is the good and right thing to do. All right. Let's try 15x to the fourth plus 5x to the third minus 27x minus 9. Is there anything these guys all have in common? Almost, but not quite. So we have 4 terms, and for the most part, anytime we have 4 terms, we try to factor by grouping. Now, that's not always going to work. So in about 3 weeks or so, we're going to be looking at how to deal with polynomials that have 4 terms when it doesn't factor by grouping. All right, so here in this first group, the common factor is 5x to the third. When I factor out 5x to the third, what's left? Well, 15 divided by the 5 is 3. X to the fourth, you take out 3 factors of x, and you have 1 factor of x left. Right, the 3x plus 1, because from here, 5 divided by 5 is 1. You took out all of the factors of x, and so it's going to be a 1. Remember, if you don't have the 1 there, at the end, you won't be able to check your work and get the right answer. In the second group, and this is what I was telling you about before, if you lead with a negative, you have to factor out a negative. If you don't do that, then you're going to be wrong. Just like up here, I needed to have the plus. If I don't have the plus and I just have this, then with nothing between the x minus 2 and the 8, it's understood to be multiplication, but that's not what we're doing. There is a plus sign here that's going to separate those, just like there's a minus sign that separates these guys. The common factor for 27 and 9 is 9. Be very careful with your signs. Negative 27 divided by negative 9 is positive 3, so it's positive 3x. Negative 9 divided by negative 9 is positive 1. So, lucky us, these guys are exactly the same, which allows us to finish factoring by grouping, so we write that in front. 3x plus 1 times 5x to the third minus 9. And as I mentioned before, if you have these factors flipped around, it's still the same, as long as you have these two factors. And the whole thing about factoring by grouping is, I mean, it's, well, I want to say it's key for the stuff that we're going to be doing tomorrow. It's not mandatory, but it is super useful. Okay. I think I've been a little bit too nice to you so far. So let's get crazy. You ready? Let's do 20 x to the fourth minus 28 x to the third y minus 50 x squared y squared plus 70 x y to the third. What should we do here? Now see, I know, but that's kind of cheating because I made the problem. What would you guys do? While you think about that, we'll take a drink. It's just water. That's all I drink. You know me. All right, so what'd you guys do? I know you're sitting there with your notebook and your pencils and your pens, doing these problems as I'm doing them. So what did you do first? Did you go ahead and make your groups? Interesting. So GCF of xy, I'm going to say no to that because this guy does not contain a y. This is kind of a bummer. Nightwolf, 4x to the third and 10xy squared. Man, that sounds like a good idea, but not quite. Oh, you're sitting at work. So are you essential where you are actually at work, or are you able to work from home? Hopefully like me, and you can work from home and you don't have to be out there with everybody else, staying safe. So Kevin, you said just x. Well, there is a correction to say just x, but there's something else. Notice that all four of these terms, their coefficients, they're all even. So that means we can at least take out a 2. And you see that if I take out a 2, that is going to be part of the GCF along with x. So it's kind of a trick here. We just did 3 problems where it was all, oh, well, I hope you stay safe out there, Nightwolf, and hopefully the customers and everybody, they do what's right, and we all get through this. So, taking out the 2x first is my greatest common factor. If you had done factoring by grouping at the very beginning, it's very easy to miss the 2x. But I'm going to show you how you can kind of see that here in a little bit. So in this first group, nope, see, I'm doing groups. What am I doing? I'm not even listening to myself. You guys got me distracted. It's all your fault. It's not my fault. It's never my fault. See, I sound just like a teenager, don't I? So take out the 2x, so you get 10x to the third minus 14 x squared y, because 28 divided by 2, and then you take off an x. 50 divided by 2, so that's minus 25 x y squared, and then plus 35y to the third. So this is my GCF, and now I'm going to take care of this stuff by doing the factoring by grouping. Now, I'm really going to do this. I'm going to create my little thought bubble here because I don't want the 2x getting in the way, confusing us. So in this group, oops, in that group, I have my common factor, which is, well, what is it? What's the common factor in that first group? Between 10 and 14, the common factor is 2, and then they both contain x squared. So if we factor out 2x squared, we have 5x. 14 divided by 2 is 7. And we took out all of the x's, so we just have y left over. Now you know that we're on a good path here because these guys right here don't have anything else in common. If they did, we would know that we missed something. We would need to go back and find that common factor again. In the second group, which leads off with a negative, the common factor between 25 and 35 is 5. They don't both have x's, but they do both have y's. And I can take out y squared from them. So let's see if this works for us. Negative 25 divided by negative 5 is positive 5. I still have the x left over, but I took out both factors of y. So I'm done. Positive 35 divided by negative 5 is a minus 7. I had 3 factors of y. I took out 2, so I just have 1 factor of y left. And now we can see how the rest of the factoring by grouping problem works. So 5x minus 7y, and that was connected to both 2x squared and minus 5y squared. So this was just the factorization for this inside part that we have right here. Now it's time to put everything together for our final answer. Don't forget about this 2x right here. This 2x is our common factor for the whole problem, so he's out here in front, times 5x minus 7y times the 2x squared minus 5y squared. And now everything is factored completely. And that's one of the key things you're going to hear, is making sure that you factor completely. Break things down as far as they can go. Make sure that nothing is left behind. Now, let's go back to something that Nightwolf said about finding the common factors. Okay, you said 4x to the third, and you said 10xy squared. Let's see how that factors in when we do it again. All right. So suppose that you just forgot to look for the common factor for the whole polynomial at the very beginning. Suppose you just saw that there were 4 terms, and you know in your mind there's some kind of trigger that says 4 terms, factored by grouping. Okay, let's see if we can do this. So here in the first group, the common factor between 20 and 28 is 4, and we can take out x to the third as well. So now we're left with 5x minus 7y. Well, that's comforting to see because we see that up here, right? So I feel like we're doing something good. Okay, between these two terms, well, we start off with a negative. Let's start there. 50 and 70 have a common factor of 10, and they both have x, and they both have y squared. So 50 divided by 10 gives me 5. I get 1 factor of x left over, no factors of y. 70 divided by negative 10 gives me a negative 7. I already took out that x. I took out 2 of the 3 factors of y, so I've got 7y left right here. So that's my big common factor. So 5x minus 7y times 4x to the third minus 10xy squared. Now, a lot of students, when they get to this point, they would say, okay, I'm good. I'm done. I factored. What else do you want from me? I want perfection. That's what I want from you. I demand perfection. There's no common factor here. But here, there is a common factor. If you look at just this guy right here, there's more to be done. You left something undone. So identify that common factor, which is 2x. Okay, so off to the side, we can see that we would take out a 2x from here, and I'd be left with 4x squared minus, take out the 2 from here, it's 5. You took out the x, and you're going to have y squared. Now this guy is completely factored. There's nothing else that you can do here, or with the 2x, or with the 5x minus 7. The only thing I would say here is about how do you want to represent, or how should you represent your complete factorization. Now, I said before that the order of your factors doesn't matter because it's all multiplication. The one caveat to that is that if you have a factor that is a monomial, a factor that's just a single term like 2x, that needs to be written in front of your problem. So you should say 2x is in front, then bring down the 5x minus 7y and 4x squared minus 5y squared. Excuse me for a second. My dog is eating something she shouldn't be. Wait. Go get someone else. Sorry about that. My dog is acting like she's hungry, but she's already eaten. So somehow she thinks that chewing a pillow is nutritional. All right, be a good girl. All right. Yeah, so we still get the same problem. We still get the same answer, no matter what. Okay? So what do you guys think? Nice and easy? So let me show you another one that you may run into that can easily throw us for a loop if we're not paying attention. All right, so let's do 8x to the third plus 6x squared plus 4x plus 3. Nice, simple problem, right? When we look at this problem, is there a common factor for everything? And the answer is no. You see stuff in the first 3 terms, but I don't care about the first 3 terms. I'm looking for the whole polynomial, and 3 throws everything off. So 4 terms, factor by grouping. In the first group, the common factor for 8x to the third and 6x squared is 2x squared. When we factor that out, we get 4x, and 6 divided by 2 gives me 3. I had 2 factors of x. I took both of those out, so I'm done. And just do a real quick check here. If you distribute this back, you should get your 8x to the third and 6x squared. And you'll notice that 4x plus 3, there's no common factor left there. For this, for that second group, we start off with a plus, and if you look for the common factor for 4x and 3, you're going to be hard-pressed to find one. Now, typically when we say there's no common factor, we're talking about there's no common factor other than the number 1. So the most that we can take out of these guys is just a 1. Now you may say, do I need to write that? Well, you don't have to, but I think in the next step it really makes it a lot easier to see where to go from here. By explicitly writing the plus 1 right here, when we finish our factoring by grouping, and I write 4x plus 3 out in front, then it's easy to see that what's left over is the 2x squared and the plus 1. A lot of times if students don't write the plus 1 here, they don't write the plus 1 here, and then the whole problem is messed up. Now, I made a mistake. Did you guys see the mistake? You just weren't going to say anything? What's wrong with my answer? Imaginary bonus points to the first one who finds it. I mean, I did everything right? This common factor, I brought that up front, and I wrote what's left over. Or did I? I had 2x squared, right? And I forgot to put the power there. Now, surely that wouldn't make a difference, right? If I had taken the time, or if you guys take the time to FOIL, to multiply this out, you would see that something's not right. Always take the time to check your work. I mean, what's someone going to say to you? Like, you can't check your work, that's not allowed? No. Always check your work. Because I'll let you know, I've been teaching for 20 years, and I still make careless mistakes sometimes. A lot of times it happens because I'm just going too fast. Surely that's never happened to you guys, right? Alright, so we've done factoring by grouping, and we've done the greatest common factor. And that leads us to the next fun part, which is factoring trinomials. So we're looking at factoring trinomials. Factoring trinomials of the form ax squared plus bx plus c, where our lead coefficient is equal to 1. So this is the first part of factoring trinomials. We make it nice and simple. If this lead coefficient is 1 and you just have x squared, these are some of the easiest factoring problems that we can do. And it's all about playing the right number game. But you've got to know what the game is so that you can follow the rules correctly. Now, I will go ahead and tell you that I do my factoring just a little bit differently than a lot of other teachers do. Okay, it's just something that works a little bit better in my head, the way I process it. You find what works for you, something that works consistently, and we're all going to be okay. So I just want you to consider the following. If I were to take the product x plus 7 times x plus 3, and I were to FOIL this out. Right, we remember how the FOIL process goes. As you multiply your first terms, your outside terms, your inside terms, and your last terms. And basically what was going on is that we were distributing. We were taking the x, and we would just distribute that out here, and we'd end up with x squared plus 3x. And then we take the 7 and distribute to the x and the 3 as well. So plus 7x plus 21. And then we just combine like terms, right? And when we combine like terms, it's a matter of combining these two guys right here to give us 10x, and then we got the 21 here at the end. But what I want to emphasize to you is that this is the product of your first terms. This 10 is a combination of the inside and outside terms of that product, and the 21 is the product of your last two terms. The 21 is 3 times 7. The 10 is 3 plus 7. And so we have the same two numbers, but we're doing different operations. To get the 21, that's through multiplication. To get the 10, that's by combining those two numbers. Now, part of the process that I do is that I tend to ignore the signs until the very end, and I deal with those guys later. Because our process is to go from here, and to backtrack is basically undoing that product to get back to the factorization. And so we're going to be playing number games. And the number game is basically coming down to this. What would you multiply to get 21? What are factors of 21 that can add to 10? And that combination is 3 and 7. And if we know that combination, we can plug in the 3 and the 7 into the factorization, and you can be done very, very quickly. But the big thing we have to make sure that we pay attention to. I tell my students all the time, is WYS. Watch your signs. We shouldn't be having an issue with the signs at this point, but sometimes we just get a little careless. We're not paying attention. Alright, so let's see about factoring here. Let's see what I'm talking about. If I were to take the polynomial x squared plus 7x plus 6, okay, I want to find a way to factor this. Now, this is a trinomial. This is not 4 terms, so we're not going to be doing factoring by grouping. Instead, we recognize that this is a trinomial, just common x squared, x, and the constant. Your lead coefficient here is 1, which is a good thing. We're going to be looking at the constant here. And the trick, at least these are the tricks that I play, is I want you to find factors of 6. Use the sign that's in front of the constant there, the plus. Factors of 6 that add to 7. Right, so you want to use 1 and 6. 1 and 6 will be the combination that's going to add to 7. And here's how we use that for our answer. X squared breaks down to be the beginning of each of these binomial factors. So x squared breaks down to be x and x. And then what we're looking at is how do we break down the 6, which is why we're coming up with the 1 and the 6 here. And the 1 and the 6 break down like this, 1 and 6. Now, the order here doesn't really matter. It's going to be 1 and 6. We probably already know what the signs are going to be here, but I want to make sure we understand really how and why, so that for the future problems, it's not like a guessing game, and we know. If I were to try to check this answer right here, this gives me 1x on the outside. I get 6x. And in order for me to end up with the correct sign for the middle term, which is a plus 7, so for me to have a positive 7x right here, both of these guys have to be positive, which means both of these guys here are positive. When it comes to the stuff that I'm doing right here, whatever the sign is of the middle term has to be the sign of the larger number. And then you got to figure out, what does this sign have to be? Now, in order for you to multiply to get a positive, there are 2 ways of doing that. They are either both positive or they're both negative. Okay? For example, if I say x squared minus 12x plus 32. First, look for a common factor. See if there's something that all 3 terms have in common. And here, the answer is no. There's nothing that all 3 of these guys have in common. So it's a normal trinomial. We see it goes x squared, x, and then the constant. We are looking for factors of 32 whose sum is 12. Now, again, I want to look at this in terms of just the absolute value. Don't worry about the signs and all that stuff just yet. So, right, Night Wolf is saying 8 and 4. That's what I'm saying too. 8 and 4 multiply to 32. They add to 12. So when I factor, I'm going to do x with 8, x, and 4. These two x's are the breakdown of x squared. The 8 and the 4, the breakdown of 32. Now, if I check this, and I'm just not worrying about the signs yet, I get 8x on the inside, and I get 4x on the outside. Now I'm supposed to somehow combine these guys to get that middle term that we see, which is a negative 12x. Right, so they do both need to be negative. I just got done saying that whatever the sign is here of the middle needs to be the sign of the larger term right here, so it's going to have to be a negative 8. And in order for us to get a negative 12, this other guy must also be negative. And you'll see that when we put it all together, it all makes sense. Everything checks out. So that means that's going to be a negative 8 and a negative 4. Take the moment to check. Negative 8 times negative 4 is positive 32. And when you combine the negative 8x and the negative 4x that you see here when I'm checking my work through foiling, I get negative 12x. Every part of this works out. And this is what you guys need to get in the habit of doing, is to check your work. And I see way too many students fail to check their work, assume they've got the right factorization, and then it just blows up on them. All right, so I want you to compare x squared minus 5x minus 6 to x squared minus 5x plus 6. Okay, these guys are clearly different polynomials. But what does that mean for our factorizations? See, whatever factorization you come up with is going to be tied to just one specific polynomial. So if you have two different polynomials, their factorizations have to be different. You can't say, hey, math man, I got one answer, my friend got a different answer, and they're both right. No, the only way that you could have answers that look different but still be right is if you have the factors in a different order. That's it. Okay, so for this first problem, I want to find factors of 6, and now this is where I tend to differ from what a lot of other people do, a lot of other teachers do. I want those factors of 6 to subtract to 5. I'm not worrying about a negative 5 right now. I'm just worrying about factors of 6 to subtract to 5. And so, check that, Night Wolf. I cannot abide the 1 and the 5 because 1 and 5 are not factors of 6. This is why I'm putting the multiplication sign over the 6. So the factors of 6 that subtract to 5 would be 1 and 6. So take the 1 and the 6, and let's go ahead and get into that factorization. So x with 1, x and 6, like that. And now it's a matter of getting the signs. Hey, now no problem. Like I said, we all make mistakes. Nobody's perfect. I may pretend that I am. Trust me, I know that I'm not. I've been married for 20 years. My wife is just helping guide me to perfection. So here I've got 1x. On the outside I have 6x. And somehow I'm supposed to end up with the correct middle term of negative 5x. But as I said before, the sign of the middle term will be the same as the sign of the larger of these two guys right here. So you know the 6x has to be negative because it has to match that sign. Now, if I have a negative 6, what does this sign have to be so I end up with a negative 5? And you'll see that it has to be a positive 1, right? Because if this were a negative 1 and a negative 6 would be the same sign, which makes them a larger looking negative number. but I'm not trying to go in that direction. So it's going to be a plus 1 right here and a minus 6 right there. Everything checks out. Now, I say everything checks out, but let's make sure you understand everything checks out. Positive 1 times negative 6 gives a negative 6. And you see here that when we add these guys, we get the negative 5x. Now, this one's a little bit different because I've got the plus sign here. So now I'm trying to find factors of 6 that will add to 5. So it's a different problem. I don't want these guys to subtract. I want them to add to 5. And if you think about the factors that you have for 6, you're going to be using 2 and 3. So when I factor this, I'm going to have x and 2 x and 3. Now it comes down to analyzing and getting the right signs. So it'd end up with a negative 5x here at the end. As I said before, the sign of the middle term has to match the sign of the larger of these two guys. If I have a negative 3, how do we get a negative 5? The other guy also has to be negative. And so we can backtrack those signs to this right here. So in terms of like what are the possibilities here? How do we know what we're supposed to do? When you look at the factors of 6, what are the different factor pairs? You have 1 and 6. You have 2 and 3. So when I do my factor pairs, I don't worry about, oh, you mean negative 1 and negative 6. No, just look at 1 and 6. I will address the signs later. When I look at these factor pairs, I want the pair of numbers that will then add to 5. 1 and 6 don't add to 5. And don't tell me, well, if one of them's negative. No, I'm not doing that. In terms of their absolute values, which pair will add to 5? And that's the 2 and the 3. That's the 2 and the 3 that I'm using there. Okay? That's how I do it. If you want to deal with signs from the very beginning and deal with all the signs with your factor pairs, you are more than free to do that. I am not going to do that. Because, as the song said a long time ago, I've got the power. Sorry, it's one of those oldies songs. You should ask your grandparents about it one of these days. All right. Let's keep on going. Let's try x squared plus 2x minus 63. Now, I'm going to show you a trick just in case you've forgotten your multiplication facts, which I know you haven't because you guys are the good ones. You're the ones that are coming here every day and you know your math, right? So, we need to find, if you don't know it from the very beginning, you need to find and list your factor pairs for 63 because what we're trying to do here is we're trying to find those factors of 63 that have a difference that can subtract to 2. That's why I'm circling this. That's why I'm showing all these notations. So yes, 9 and 7, that's correct. But what if you forgot it? What if you did not remember that? Well, you can do things the long way. And you can go to your calculator and you can say, okay, well, I do know this. I know from the very beginning that I've got 1 and 63. That one's pretty clear. I could try... Let's just find the right place for this. There we go. Now, this pains me to do this. 63 divided by 2. Okay, well, it doesn't go in evenly. I can do 63 divided by 3. Hey, that goes in evenly, so I've got the factor pair of 3 and 21. Now, in terms of the math logic about all of this, if 2 didn't go into 63 evenly, no other even number will. So don't even try 4. 4 is a waste of time. Let's try 5. But you already know 5 doesn't go into it because for a number to be divisible by 5, it has to end in a 5 or a 0. But you know what? If you just didn't believe me and you wanted to go to the calculator anyway, boom. See? I was right. See? Told you. Can I divide by 6? No, because it's an even number, and we already discussed that. 63 divided by 7. And there you go. You get 7 and 9. I don't have to worry about 8 because I already told you why not. And then we get to 9, and that guy's already spoken for. So these are the only factor pairs that we have for 63. Here is another way of doing that if you have a graphing calculator and you just really want to go full core into this. If I go to y equals, pretend you didn't see that, and you type in 63, so that's the constant that we have here, and you say divide by x. And then we're going to go to our, you know what? I gotta make sure the table setup is right, and it wasn't. If you go to the table, this is going to show you all of the possible factor pairs that we have. So as you scroll down here, of course there's 1 and 63, there's 3 and 21, right? Let's see, that's decimal, keep going, 9 and 7. So this is going to help you find all of those factor pairs in case maybe you don't have them, or you don't know how to do the division well enough, or you're afraid you're going to miss something. This is going to tell you everything. Now, I don't need to keep going here, because once I get here to 9 and 7, that's the same thing as 7 and 9. So I'm starting to cycle back up, and I can go ahead and stop. So we've already identified that it's going to be 7 and 9. So when I factor this, it's going to be x and 7, x and 9. So 7x on the inside and 9x on the outside. So somehow, with my signs, I'm supposed to get a positive 2x. To get a positive here at the end, that means the larger number has to be positive. And since this was a minus here, we already knew the clue was going to be these guys have to have opposite signs, one positive and one negative, which means the other guy has to be negative. So it makes that negative 7 and positive 9. And there we go. And I'm going to tell you that the more of these you do, the better off you're going to be. You have to practice. That's all this is practice. Okay? Oh, now I just showed you a neat trick that you can do on the calculator. So let's see how that can help us out when it comes to this problem. Let's do x squared plus 25x plus 144. So there is no common factor other than 1. I now need to look to the 144 and see if I can find factors of 144 that add to 25. Now, I've got a feeling that this is not going to be something that you just know off the top of your head. And that's fine, okay? What we can do is we can go through this systematically, like I was saying before. Off to the side, let's look at 144, and let's see if we can come up with all of the factor pairs for 144. Well, we've got 1 and 144, and then we're just going to have to go through everything else, right? Unless you know. Or we can use the graphing calculator to help us see what all of those factor pairs are. Now, we know that 144 is even, so I can at least do 2 times 72. What about 3? What about 4? Let's see what this says. So I'm going to go back to the y equals, and I'm going to change this from 63 to 144 divided by x. I can go back to my table, and it's going to repopulate everything. So in the left column, it's going to tell me all of my factors of x, and it's going to tell me whether or not it goes into it evenly. You see here at 5, that's a decimal, so it's not going to work out that well. Right, so Kevin, you already have 9 and 16. Did you just go through, did you crunch it by hand, or were you using the graphing calculator? Just want to know if maybe the graphing calculator thing helped. So as I go through this, we've got 3 times 48. Then we have 4 times 36. 5 doesn't work. 6 goes in 24 times. 7 is trash. Oh, 8 and 18. Then we get to 9 and 16. And if you go all the way to the end of the line, you get 12 and 12. These are all of the factor pairs for 144, so if there's going to be a way for this problem to factor, we have to find it among these factor pairs over here. And in order for us to add to get 25, that's that guy right there. So whether you have a graphing calculator or not, you can still go through this systematically, trying everything up to this point. Because once these guys are the same, there's no point to go on beyond that. But you can at least, one at a time, go through this. Don't skip numbers. Because a lot of times when you skip, you end up skipping that one pair that's your answer. So here's 9 and 16. Note, everything here is positive, which means these guys are both going to be positive. It doesn't take too long to check. On the inside here, you get a plus 9x. And on the outside is a positive 16x. And altogether is a positive 25x. All right? Let's make sure that we completely take out the mystery from factoring. Any of my students will tell you that factoring is one of my favorite things to do. I don't know why. I guess maybe it's because I'm solving a puzzle. Maybe it's because of the logic that's involved. I love it. It's just an absolute blast for me. All right. Let's try x squared minus 3xy minus 40y squared. Now, if you look at this, you might think there's a common factor to take out, but there's not. These guys have x, these guys have y, but nobody has all x. There's not everybody that has y, so this problem is actually easier than you might suspect. X squared is still going to break down as x times x. Not only that, but with the 40y squared, the y squared is going to break down just like the x squared does, and it's going to go y and y. And as Nightwolf is saying in the chat, we're going to use 8 and 5, because kind of ignore the y for a moment. What are factors of 40 that subtract to 3? And yeah, that's going to be 8 and 5. Now you can say 8 and 5, 5 and 8, doesn't really matter. So let's say 8 and 5 like that. And since the middle sign here is negative, we need to make sure that the larger of these numbers keeps that sign. And the other part here is going to be positive, so that we end up with a negative 40y squared. You might say, does this really work out? Negative 8 times positive 5 is negative 40. The y times y is y squared. On the inside, that's negative 8xy. On the outside of the product is positive 5xy. These guys are like terms, and they combine to give us the negative 3xy that we were supposed to have there in the middle. So everything here, absolutely everything, checks out. See? It's really not that bad. What a lot of students forget about is they forget that there's a y squared there. And they tend to just go straight to x minus 8 and x plus 5, and they forget about the y. But you know what? It happens. But no, I'm going to take that back. It has happened. But it's not going to happen again. Because we're here to learn. We're here to get stronger. This is like your online PE class, except we're doing math, right? Now, speaking of special factoring things where we have the y squared, suppose I give you this and I say x to the fourth plus 11x squared plus 30. Now, this doesn't follow that normal pattern for being x squared, x, and the constant, but it still has a very similar process behind that. See, we broke down x squared as x and x, and basically you're taking these two factors of x and you're splitting them up. Well, now that I have 4 factors of x, I want to split those guys up evenly as well and do x squared and x squared. So that's how I'm going to lead this guy off. I'm going to do x squared here and x squared here. And then it's a matter of coming back to the 30, finding factors of 30 that can add to give us 11. So the same kind of factoring techniques and the same thought process is still going to be true here, except now we have to deal with x to the 4th. So the factors of 30 that add to 11 are 5 and 6. And the signs, since everything here is positive, these guys will both be positive as well. Again, verify that this is correct. X squared times x squared is x to the 4th. Positive 5 times positive 6 is 30. And when you check inside and outside, there's 5x squared. And there's 6x squared. So altogether, we got 11x squared for the middle term. So it all checks out, right? No problems whatsoever. Well, think you guys could do another one just like that? You know what? I know you can. So let's do this. X to the 4th minus 10x to the 3rd minus 24x squared. So, what do you think we should do here? What are the numbers? What are you thinking about? What do you think is going to work best for us in this problem? See, man, I was trying to trick you guys. There is a common factor that we have to address first. You can't just say, oh, well, I got to break down x to the 4th as x squared and x squared. No. There's a common factor of x squared that has to be factored out first. When we do that, x squared minus 10x minus 24. All right, so the next part here, we've got to pay very close attention to our signs so that we know what our factors are supposed to be doing. I want factors of 24, and I want those factors to subtract to 10. And when I say subtract, I mean in terms of their absolute value. So if I go up to the side here and I look at 24, I've got 1 and 24, 2 and 12, 3 and 8, or 4 and 6. So what is the pair that will have a difference of 10? 4 and 6? Well, if I look at these guys in absolute value, the difference between 4 and 6 is 2, not 10. It's going to have to be the 2 and 12 right there. It's one of those things like one sign can totally change the problem here. So it's the 2 and the 12 that I want to use. So this is x squared. It's going to break down as x times x. I'm going to use a 2 and a 12. And as we mentioned earlier, the sign of the middle term is going to be the same sign used for the larger of these two numbers. So this guy has to be a minus. And in order for us to multiply to get a negative at the end, that's using a negative times a positive. Check this very quickly. Positive 2 times negative 12 is negative 24. When you check what's on the inside here, plus 2x, and on the outside is minus 12x, that gives you negative 10x. That's the right middle term, and so we're good for that, right? All right. Let's try x squared plus 6x plus 4. This is a normal looking trinomial. trinomial. Is there a common factor? No. There's nothing that we can take out of all three terms except for 1, but if you're factoring out 1, that doesn't really do a whole lot for us. So this has a lead coefficient of 1, so it's good. Can you find factors of 4 that will add to 6? And this is where we run into a problem, because you can't find factors of 4 that add to 6. If we can't find factors of 4 that add to 6, that means we can't factor this. And so the correct response here would be prime. This polynomial is prime, which means it can't be factored. That means there's not even a common factor to take out. There's no way of breaking this down at all so that you have multiplication. This guy is done. He's finished. Okay, so prime means that this guy cannot factor at all. And he's done. Now, granted, this is not something that you run into a whole lot, especially if you're doing homework exercises where the instructions are to factor or factor completely. I mentioned that because I had a student one time, I had a handout that had 80 questions on there, and I think he must have given up because for like the last 40 he said they were all prime. They weren't. I think out of the whole handout there might have been 1 that was prime. So again, it's not a common occurrence, but it is something that you need to be mindful of. Alright, well, appreciate you guys stopping by. Kevin, Nightwolf, anybody else who may be lurking in the chat. Well, I'll be uploading this video, putting those timestamps on there, so feel free to check out YouTube later on for that video. If you need to share that to anybody, please do that. Again, I do it for the love. Stay safe out there, and as always, remember, before you do anything, what would Mr. Craig do? All right? Have a good afternoon.